Hi there, welcome back to the Formulaic approach channel. Let us see derivative of logarithmic functions. Now let's see how to solve, to differentiate logarithmic functions. Now there is a general formula, or more like a formula that you can use whenever you are given your, to differentiate a function y equal to ln x, for example. Now what you basically do is you differentiate this function, or let's say ln f of x, for example. What you do is you differentiate this function, and then you have f prime of x all over f of x, okay, dot 1 over ln e. Now in this case, ln e will be 1, so it will be 1 over 1. Is that okay? So when you have one that has a natural log, all you do is just differentiate the function over the function. Is that clear? When you have ln a function, the ln of a function, natural log of a function, you differentiate that function over the function. So why? What if you were told that y? Because here, first let me tell you why. Here, this ln means log to base of exponential f of x. So that is why if you differentiate, you just have f prime over f of x, and by the time you take natural log of e, you're going to have 1, okay? So what if you now add log to base a particular constant of a function f of x? The same way, differentiate this guy, so dy dx in like manner will be derivative of f of x over the function itself, f of x itself, then multiply by 1 over ln of your base, the natural log of your base. Is this clear? Derivative of this logarithm to a particular base that is not base e is going to be derivative of the function over the function times 1 over ln of your base, natural log of a base, okay? So since we already know that, let me just give you what, for example, if you have log to base a, or let's say to base e first, that's ln x cubed plus 2x squared. For example, before we use those questions, I just want you to see this. If you are told that y is this, then dy dx will be equal to derivative of this, that what? 3x squared plus 2 plus 4x all over this guy, yeah? The function itself, right? So that will be x cubed plus 2x squared. Then multiply by 1 over ln of the base of the exponential, which is e. So ln e will be 1. So this will be our answer. Is it clear for this question? So let's solve the questions I have on the board. So we have number 1 says that y is equal to x ln x. Now with this, we know we have products, right? So we use product rule. Is that okay? Now what is product rule here? What does product rule here say? It said we should hold one, differentiate the other, plus hold the other that we differentiated before and differentiate the one we held before. Okay, so we have dy dx here is going to be, let's hold this first. By the time we hold x and differentiate ln x, if you differentiate ln x, use the approach I taught you. Simply differentiate the function itself, which will be 1 over the function, then ln e, right? So this will be ln x, derivative of 1 over, derivative of ln x will be what? 1 over x. Okay. Alright, so what we have will now be equal to x, we hold x, and then take the derivative of this, which will be 1 over x, then plus, now hold ln x and differentiate x, that will be dot 1, right? So this takes care of this, that gives you 1, so that dy dx will now be equal to 1 plus ln x, and that will be our answer. Okay, so let's do number 2, which says that y is equal to e to the 3x ln x. Now look at this. We're going to use product rule again. So that dy dx will be equal to, this time again, we'll hold the first one. So that will be e to the 3x dot, differentiate the second term, that will be dot 1 over x. Derivative of ln x is 1 over x, right? So plus, now this time, hold this one and differentiate this. So that will be ln x dot, let's differentiate this guy. Derivative of this will be, first differentiate this function on top, that gives you 3, dot, then derivative of everything. If you remember, if I've already done, I've made a video on exponential, derivative of exponential function, so I'll link it in the description so that you understand what I did here. Differentiate this guy, gives us 3, differentiate the entire thing, gives you the same thing, 3x. Okay, so what we'll have here will be dy dx becomes e to the 3x over x plus ln x rather. So let's write this first, 3e to the 3x ln x. That's all. Okay, so with this you see that e to the 3x is common, so we can factor it out so that dy dx becomes e to the 3x e raised to the power of 3x into bracket, here we left with 1 over x, right? So plus this leaves here, we have 3 ln x. So this is going to be our answer overall. Okay, we can't simplify further. So then number 3 will be y equal to x log to base 2 of x. Okay, so now we don't have a natural log here, we have log to a particular base actually now. So dy dx will be equal to, we hold this x and we differentiate this. Now how do we differentiate that? Remember, differentiate this function first. If we differentiate the function, it will give us 1 over the function itself, that is x. Yeah? Then multiply that 1 over, in this case, ln of the base, that is ln of 2. Does that make sense now? Ln of 2. If it was ln of e, it would be 1, so it will not appear. But in this case, it is another base which is 2, so it will appear there. Then plus, now we hold this, that will be log 2 base, log x base 2 rather, log x base 2. Then we differentiate x. By now we differentiate x to give us 1, right? So our dy dx will now be equal to, this takes care of this, now the 1 over ln 2 plus log x base 2. Okay, so we can even simplify further. Let's make both of them base of exponential so that it become dy dx equals 1 over ln 2 plus, here becomes log to base e of x and log to base e of 2. Okay, so this is now ln, this has become ln x over ln 2. Okay, so if that's the case, then we can bring this, this is ln, log to base e is ln, okay, of x. So we can now say that dy dx is equal to, we take the LCD, or just like we are trying to merge the fraction so that we have ln 2 is our denominator now, then 1 plus ln x on top. I guess this will be the final answer then. Alright. Then the next one is number 4. Number 4 says that 9 sine 9x ln x. Okay, so how do you do this? Using the same thing, dy dx, using the same product rule, dy dx will be equal to, we hold this sine 9x, differentiate ln x, that will give us 1 over x, plus we hold this ln x and differentiate sine 9x. So to differentiate sine 9x, differentiate this first. 9x will give us 9, right? So when you take that, it gives us 9 dots. Then differentiate sine of this. Sine of this will be cos of this. That will be cos 9x. So that we have dy dx to be equal to, this takes care of this. That is sine 9 okay, sine 9, okay, plus, well, except if we need to calculate, but maybe sine 9, I mean, like to resolve this, that's what I mean. Then plus ln plus 9 cos 9x ln x. This is going to be the answer then. Sine 9 plus 9 cos 9x. There's nothing we can do further. Yes, there's nothing we can do further. So that's going to be the answer. That's going to be the answer. All right, let's go to number 5. Number 5 says that y is equal to ln x over 1 minus x cubed. Okay, so in this case we use quotient rule, right? And quotient rule says that bottom the top minus top the bottom over bottom squared, right? Okay, so basically it's saying that we will hold this and differentiate the top so that dy dx therefore becomes, hold this, differentiate the top, 1 minus x cubed, differentiate this, gives us 1x minus, hold u, that is ln x, differentiate v, v is this, so let's differentiate this, it gives us minus 3x squared, okay, all over bottom squared, 1 minus x cubed all squared. Is it clear? All these differentiate this, okay? All right, so dy dx therefore becomes 1 minus x cubed all over x minus, now plus, it becomes plus, right? Minus times plus, minus and minus plus. So you have plus 3x squared ln x. Everything over 1 minus x cubed over, okay, all squared. Okay, so let's just bring this guy, you know, this is this plus this. So we could decide to, this guy is ln x dot this okay, so if we multiply through by x, let's multiply through by x. If we multiply everywhere here by x, then we'll have dy dx will be equal to x multiply this, it takes care of this, it remains 1 minus x cubed plus, multiply this, you have 3x cubed ln x all over x into bracket 1 minus x cubed squared. So this is going to be the answer. We'll multiply this one, denominator and numerator, by x. Okay? So x will take care of, as in this is what I mean, by x, so that this will take care of this, and this will multiply this. Okay? So that's the answer then. Then number 6, which is the last one. Okay, number 6 says that y is equal to ln x over x. So I'm going to be using quotient rule the same way, so that dy dx will be equal to, we are going to hold this x and differentiate this, it becomes 1 over x minus, we now hold the top, that is ln x, and differentiate the bottom, that is 1, all over bottom squared, that is x squared. So we now have, this takes care of this, and we have 1 minus ln x over x squared, and that's all. Oh, that's all. Alright, so that'll be it. Do want to subscribe to the channel and share the video with your friend. And of course, the channel is about science, mathematics, and math and science generally. So if you have any question, do want to drop them in the comment section and reach me out on my WhatsApp number. If you need more questions on this, I have an archive of many questions that you can use to solve, to help yourself, all right, to learn it the more. So God bless you as you subscribe.